Welcome everyone to NSF NOIRLab Town Hall. My name is Patrick McCarthy. I'm the director of the lab. I'm delighted to have you here with us. Over the next little while, we're going to talk a bit about the organization of this new entity for ground-based OIR astronomy, talk a bit about our mission and our vision. We'll then hear from each of the program directors about the exciting things going on within their programs now and for the year ahead. Just a reminder, if you'd like to ask questions or offer comment, please do that through Slack. The Slack channel is listed there. We are meeting number 420, so it should be easy to find amongst the many channels here at the AAS. So let's just dive right in. First, I want to Willman, who is also the slide changer. She's the driver here. Beth is the deputy director. We also have recently appointed Inger Jorgensen as our associate director for operations. Today we have with us Jennifer Lotz, the director of the Gemini Observatory, Bob Lum, the director of Rubin operations, Lori Allen, who's the director of the mid-scale observatories, that is Kitt Peak and Cerro Tololo, and Adam Bolton, who is the director of the Community Science and Data Center. In addition, we have the leaders, the directors of our cross-cutting matrix organizations. We have Abhi Saha, who is the director of research and science services, Nikhil van der Hoven, who's the director for engineering services that support all of the programs, and John McLean, who's director of center operations that keeps everything running smoothly at all of our sites. And then importantly, we have with us Lars Christensen, who is the head of communications, education, and outreach, the person who spreads the message around the globe about all the great work that we do. Today, you'll be hearing from the program directors about the exciting things going on at their observatories. You can then go to the next. Remind you, if you're not familiar with what we are, NOIRLab is the unification of all of the NSF's nighttime optical infrared astronomy facilities. That's Kitt Peak in Arizona, Cerro Tololo in Chile, the Gemini observatories north and south that are run with our international partners. And then the operations of the Rubin Observatory, which is a partnership between the National Science Foundation and the Department of Energy's Office of Science. Last and by no means least is the Community Science Data Center that ties all of this together. They provide services to users, they provide data archive, time allocation, software support, everything that helps you turn your data into science or your idea into a proposal that then leads to data to science. So that's what we are. It's a just distributed organization, but it brings together some very powerful assets. Next, I think it's important to remember that we operate these observatories in land that often belongs to indigenous people and in all cases is of great cultural significance to them. And we take very seriously our responsibility to be good stewards of the land, to work with the local communities, to respect their cultures, their traditions, and really be good partners with them as we occupy and use their land. I think it's been really gratifying to see the society host special sessions at this meeting that we all expected to be in Phoenix, that brings together the leaders of the local communities in Arizona, in the Southwest, the Pacific Northwest, and in Hawaii. Informative and uplifting, and it renews my commitment and the commitment for all of us to be good citizens on the land that we use to do our science. Next, I imagine many of you are interested in how we are coping with the coronavirus. We've been hit with it like everyone else. We closed all of our observatories in mid-March. We are unfortunate that Chile and Arizona were particularly hard hit by the COVID in June and July, respectively. They really experienced massive surges in infections. Hawaii had a smaller surge later in the summer, but fortunately, due to the advantageous conditions in Hawaii, we were able to bring Gemini North back on the sky in mid-May, and all of our other sites have been back on the sky since late September. All the observatories are functioning, science is being taken, observations are made on essentially every clear night, and all of the observing modes are working. As you may be aware, right now, Arizona is experiencing another outbreak of COVID, the one they had over the summer. We were able to continue operating at Kitt Peak thanks to the work that they did over the summer and putting in place the necessary equipment and protocols to ensure that we can operate safely. I want to thank the National Science Foundation for being really strong supporters and partners through all of this. They've really been very helpful. We could not have gotten through all of this without their support. I also want to thank AURA as an organization for helping support all of this. And the various AURA centers have worked together, particularly the AURA NSF centers, the National Solar Observatory, and the two construction projects, Rubin and DKIST. We've all worked together to take a common approach to this. And I think that's helped us to manage in this challenging time. The good news, though, is all the telescopes are on the sky and we're continuing to do science. If you'd like to stay in touch on this, just visit our website. We post updates regularly about our COVID status. Next, it's important, I think, before we delve into the details to step back and ask, what is this organization all about? What's it for? We're a national laboratory for optical and infrared astronomy from the ground, and our mission is simple and clear. That is enabling breakthrough discoveries in astrophysics with state-of-the-art ground-based observatories, data products, and services for a diverse and inclusive community. Let me just parse that a little bit. So the first part, enabling breakthrough discoveries. Of course, that's what we're here for, is to allow all of our users in the US, in our international partners, in our own scientific staff to do great science. And we want to provide them with the tools in the form of state-of-the-art telescopes, instruments, adaptive optics, and other systems. And you'll hear about that in the remainder of this presentation. But there's more than just observing. We need software and support, a means to turn the raw data into high-level data products, and that's a key part of our mission. And lastly, but perhaps most importantly, is we are committed to removing as much bias as is humanly possible, and to go beyond that, but create new opportunities for groups and individuals who've not been able to engage in astronomical research in the past. We want to lower the barrier and create new avenues for more people to do astronomy from diverse walks of life, and that's key to our overall mission. We've then taken this mission, and from that we've evolved a vision for the next 20 years of the organization, and from that vision then we've flowed down our goals for the 2020s, and they're summarized on this slide. I won't read them verbatim, but they're about a few basic themes. One is we want to be creating a world-leading or world-competitive capability in data-intensive and wide-field survey astronomy. We want to push back the frontiers in the new area of time domain astronomy by providing an unequaled suite of capabilities. At the same time, we want to make sure that we enable a wide variety of discovery-driven science, science in which the quality of data is more important than the quantity. And that ranges everything from adaptive optics to precision Doppler spectroscopy and much in between. We see it as important for a national center that we engage with the community, that we lead discussions around new directions related to planning and implementation. In particular, when the decadal survey results come out later this year, we will work with agencies and their advisory structures to ensure that the recommendations from the planning process are turned into reality. And then mid-decade, it will be time to start thinking about the 2030s and looking at advanced planning and development to ensure that we have a strong portfolio going into the next decadal survey. Lastly, but again, not least by any means, is we aim to be an agent for within our own organization, within our profession, within society at large. And that means being inclusive, it means being diverse, and it means communicating to the world the wonders of astronomy and the benefits of the scientific method and its importance to society. And on that note, then I'm going to turn the floor over to Beth Willman, who will talk about these last two topics, and then we'll work our way through the various operating programs, all of whom will touch upon these same goals as they describe to you what they're doing now and their plans and priorities for the remainder of this year. So Beth, over to you.
Great, thank you, Pat. Hi, I'm Beth, and I'm pleased to just briefly tell you a bit about this topic of being an agent for change, and also our approach to engaging with the user community through a set of formal committees. So as a lab, we want and need to develop and engage an active set of users that is representative of the broadest possible research community. So as Pat said, we can accomplish our ambitious goals. so that we can explore the largest volume of discovery space. And frankly, as Brian Nord put it in his excellent plenary on Monday, so that we can do the right thing and what's right for society. We also need, as Pat's already said, we need to be conscious of the privilege in operating on Mauna Kea, on Kitt Peak, and in Chile. And it's imperative that we listen to, we learn from, and we respectfully collaborate with our local and Indigenous communities and colleagues. And so to do this, the lab needs to embed culture and actions in support of diversity and inclusion in everything that we do. And so in this town hall, we'll talk specifically about just 3 aspects that we're actively working on. The first I'll talk a bit about on the next slide, which again is user community engagement. You'll hear from Adam Bolton about a dual anonymous proposal review that is under development in the Community Science and Data Center. And you'll also hear in detail from Adam Bolton and a little bit from Jennifer Lotz about open data access in tools and how that can increase the accessibility of discovery, of breakthroughs discoveries with the lab's tools. Now, all 3 of these topics have been written about and spoken at length by Dara Norman, who's the Deputy Director of our Community Science and Data Center. And so I really encourage anyone who's interested in these 3 specific things that we'll be brushing on in this town hall to look up what she's written and presented. And in fact, at the last summer AAS meeting, AAS 236, Dara gave an invited plenary talk on the inclusion revolution. And you can easily find that and watch it on YouTube. I highly recommend it. So, engaging with our users and our potential user community is really fundamental to our mission. Our engagement with the users is everything from getting advice and input from you to engaging and having interactions in this meeting, whether formally or informally, our training sessions, workshops, different sessions, and this slide itself focuses really just on the formal aspects of what's really a multidimensional way that we work to engage all of you and support you to do science with our facilities. So this slide highlights both committees that have been in place for quite some time, such as our users committees, telescope allocation committees, Gemini Science and Technology Advisory Committees, and then also some new things that have recently launched or will soon launch, prompted by the recent standing up of this new integrated lab. Now, when we're standing up new committees or appointing new members to existing committees, we always need to refresh and add members to committees. We're working to ensure that the committees themselves are representative of the broadest possible user community. We're working to make sure that the committees themselves are run with attention to best practices in running inclusive meetings. And also, especially for the higher level advisory committee meetings, to make sure that folks on the committees don't just feel like they're invited to represent themselves. This is what I think is Beth Wilman, that astronomer who likes dwarf galaxies in the universe, but instead to think broadly about the type of community that you're coming from and to represent the needs and interests of that community. For example, I used to be a professor at a liberal arts college. So when I serve at a community even now, I think about the unique needs and opportunities present at undergraduate serving institutions. Now, President Scody kicked us off, the whole meeting off on Monday morning by encouraging junior astronomers to volunteer for things that you're interested in. There's a lot of different ways to get engaged with the lab, not just expressing interest in user committees, but also to, like I said, attend workshops, apply to summer schools. The Chile Summer School and Data Science applications are now underway. So please come by the after party in the NOIRLab booth at AAS if you would like to connect. Send us a Slack or email anybody on this panel if you'd like to connect with any of us. So now I'm handing it over to Jen, who will talk about Gemini Observatory. Jennifer Lotz, over to you.
Thank you very much, Pat and Beth. Yeah, I'm Dr. Jennifer Lotz. I'm the director of Gemini Observatory. With this slide, I wanted to highlight the wide range of activities that Gemini is doing that ties into the broader NOIRLab strategic vision for the next decade. So Gemini has been thinking about time domain astronomy for a while, actually, and our aim is to become the go-to 8-meter class facility for follow-up, a rapid response follow-up in the era of Rubin Observatory operations. So along those lines, we have a number of activities. We're coordinating with our NOIRLab partners and Las Cumbres Observatory to become part of a network of telescopes known as AAON, to be able to really enable very rapid and flexible response for time domain astronomy and other astronomy. We're working on our software infrastructure to provide a modern system for proposers and users in this era, and that's called the Gemini Program Platform. We're building a new instrument, which is called Scorpio, which is a fantastic multi-channel imager and spectrograph that will be available at Gemini South to be able to enable rapid response to time domain events, but also be a workhorse instrument for lots of different science cases. We're doing a lot in the era of high precision astronomy, and I'm going to talk a little bit more about our new precision radial velocity instrument, a visiting instrument known as Maroon-X, and other high resolution spectroscopic capabilities available now and in the near term. I won't have a chance to say very much about our exciting adaptive optics future. We are being funded by NSF through a program called Gemini in the Era of Multi-Messenger Astronomy. And one of the aspects of that program is to bring a new adaptive optics facility to Gemini North. Finally, we're working with the lab and with our partners to up our game in terms of data reduction, analysis, and the availability of data to the broad Gemini NOIRLab community. So we are working on a new Python-based software data reduction package called Dragons. And we're also partnering with CSDC's Data Lab to better provide Gemini data products to the entire astronomy community. And I'm happy to answer any questions about any of these aspects. Next slide, please. So as Pat mentioned, we're very fortunate. We have both Gemini North and South operating and on sky nightly. And yes, I'd like to thank NSF, Aura, and our staff for really persevering and making this possible. We have a number of observing proposal opportunities coming up. The next opportunity is our monthly fast turnaround call that's due January 31st. We've decided to go ahead with our annual call for large and long programs. Letters of intent are due February 8th, and the proposals are due April 1st. And we're also having our usual semester call, and those programs are due April 1st. Both Gemini North and South are also accepting director's discretionary and poor weather proposals. Those can be submitted at any time. Next slide, please. So as you're thinking about your proposals, I wanted to highlight some of the exciting capabilities we are having now. So iGRINS is a visiting high spectral resolution near-infrared spectrograph developed by the University of Texas and CASI that's currently operating at Gemini South, and we'll be accepting proposals. We're also very pleased to be able to offer now Maroon-X, which is a high precision and high spectral resolution red optimized spectrograph, which I'll say a little bit more about. That's at Gemini North now. We have received the shipping containers for GHOST, which is a high resolution optical spectrograph at going to Gemini South. It was sitting in shipping containers on the Recinto for quite a while, and we're very pleased that we've now been able to move that up to the summit. When COVID conditions permit the team members to actually come for commissioning the Gemini South, we'll be doing that, and that's one of our highest priorities once travel conditions permit that. Next slide, please. So I wanted to spend a little bit highlighting Maroon-X. This is an exciting new capability at Gemini North. This is a visiting instrument built by Jacob Bean out of the University of Chicago. And the primary science case for this is to be a new radial velocity instrument for M dwarfs. And the goal for this instrument was to reach better than 1 meter per second precision for late M dwarfs out to 30 parsecs. This is a spectrograph that's covering the 500 to 900 nanometer range at a spectral resolution of about 85K. And it's of course designed for high precision radio velocities, but can also be used as a general purpose high resolution spectrograph. It's fully operational and it's available now for proposals to the entire Gemini and US astronomical community for proposals. Next slide, please. And I want to thank Jacob for sharing this very recent slide. These are results from September observations. This is showing the best ever radial velocity performance for an M-dwarf, reaching radial velocity precisions approaching something like 30 centimeters per second. Next slide, please. So finally, I wanted to highlight a number of activities that have been happening over the last week at the AAS meeting, describing the ways in which Gemini and NOIRLab is getting ready for the era of time domain astronomy. Last Friday, we had a science writers workshop focused on the theme of multi-messenger and time domain astronomy. The recording of that workshop is now available. There were some fantastic talks, not just from Gemini, but from Rubin, from LIGO, from the Event Horizon Telescope and the Las Cumbres Observatory. One of the other things that we highlighted in that workshop was a white paper that we are releasing and as part of the GEMMA program, which describes best practices for scientists and communicators on how to communicate these themes for multi-institutional science collaborations. As I'm sure you're all aware, this new era, it's very complicated and very challenging. And so I think there's some really great recommendations in that white paper. On Monday, we had a demo, a preview of what will be coming in this new Gemini program platform, the set of tools for proposers and observers. That demo was recorded, so I also, if you're interested in a sneak peek of what will be coming, please watch that. That's some really exciting new ways of, and better improved ways of proposing and using the Gemini telescopes. And then on an almost daily basis, we've been having demos of our new Python-based data reduction package, DRAGONS, which stands for Data Reduction for Astronomy from Gemini Observatory North and South. The next demo will be tomorrow afternoon, and I encourage you to check that out. We currently have all of the Gemini facility imaging modes available with this software package, and we're working very hard on being able to release long slit spectroscopy modes next. So thank you, and with that, I'll hand it over to Bob.
Thanks, Jen. Hi, everybody. It's great to see you here at the NOIRLab Town Hall. My name is Bob Blum, and I'm the director of the Rubin Observatory Operations. Just as a reminder to all of you, the Rubin Observatory is an NSF and DOE partnership managed by Aura and SLAC. So within that entire partnership, Rubin Operations is part of NOIRLab, while the construction project is not. The Vera C. Rubin Observatory mission is to create a vast astronomical data set and web-based analysis environment for unprecedented discovery in the deep and dynamic universe, all for you to do your science. We will do that by covering the southern sky every few nights for 10 years and putting the data on our science platform for every astronomer in Chile, the United States, and select members of our international community. As an integral part of NOIRLab, we want to make NOIRLab the leader in wide field astronomy from the ground. Of course, the Rubin Legacy Survey of Space and Time will be even more powerful when connected to other surveys. Two that have particular interest for our community are the space-based Roman and Euclid surveys. We have started to coordinate now with members of both Roman and Euclid and plan for this amazing future. As part of NOIRLab, we are also connected to a wealth of follow-up resources, including 4 and 8 meter telescopes and the follow-up network called AON. We will strive to be the most powerful engine for time domain astronomy in the world in the coming years. Next slide, please, Beth. Given COVID delays, we are now planning for an October 2023 start to the full survey operations. This will have followed engineering first light, which would be in about May 2022 on our current schedule, and the first light for the main camera, or LSST cam, about October of 2022. 2020 was extremely challenging for Ruben, just as it was for all of you, I'm sure, as well. But we are happy to report that great progress is being made once again in California at SLAC and in Chile on Cerro Pachon. The dome is nearly closed up, and our team hopes to restart assembly of the telescope in February. This is an image of Vera Rubin working in her lab, and it was captured in our lab at SLAC with a pinhole projector and the fully working science focal plane. LSST cam is well on its way to completing final integration. Next slide, please. In pre-operations, one of the most important things we're doing is developing the detailed plan to execute the LSST. We're standing up 4 departments in order to execute the survey. Observatory operations will take data every night from Cerro Pachon in Chile, sending raw images to our data production team, who will process the images at our facility at SLAC and make alerts on transient events in the night sky every 60 seconds. Those alerts will be available to the whole world in real time. Data production will also produce catalogs and coads every year and make them available to you through our science platform. Our system performance team will validate the data and ensure the whole system is running as designed. And we'll use the data to inform, engage, and educate the public, including through a dedicated citizen science program. We'll do this over and over pretty much every night for 10 years. Our team is ramping up this year. We have about 100 people working on pre-operations. That's 40 FTE of work planned this year as we look towards starting the survey in a couple of years. 2 important activities that we're doing this year are gaining experience for operation in our Google Cloud-based interim data facility and delivering an in-kind program that will bring significant added science resources to the science community. Finally, we are always in close coordination with the construction project, planning for a smooth and effective transition into operations. And the last slide, please, Beth. So how will Ruben engage with the community? Of course, instead of telescope time, our primary connection to the community is through data products, nightly and annual. We will begin this year with simulated LSST data from the Dark Energy Science Collaboration. These data will be made available through the interim data facility in mid-year and mark the beginning of hands-on work for the community in Ruben operations. Come see us at the booth to understand more about this opportunity. In operations, users will connect with data products via the Ruben Science platform at our US data facility hosted by SLAC and other centers, including the NOIRLab data center. The primary interface for Ruben support to you is the community engagement team. They will manage community.lsst.org, which is an interactive site for user crowdsourced support and will be our primary knowledge base. You can connect there now and start learning about Ruben and the LSST. Our goal is to do all of this while engaging deeply with the community, including with scientists, educators, and students from smaller and underserved institutions. LSST is an opportunity to reach communities in ways and at a scale that we have not done before. Thank you, and I'll pass it on now to Adam Bolton.
Thanks, Bob, and hi everyone. I'm Adam Bolton, Director of NOIRLab's Community Science and Data Center, or CSDC. We focus on astronomical data science and community user support with very strong connections to all of NOIRLab's observatory programs led by my colleagues here on the virtual stage. CSDC's vision as part of NOIRLab centers on 3 major themes in particular. Those are listed here. There's survey scale and data intensive astronomy, time domain and multi-messenger astronomy, and broadening participation through open access. And importantly, in the 21st century, as Pat already introduced, open access includes access to telescope time, and it also includes access to data and to user support. So to achieve this goal, CSDC currently operates NOIRLab's peer-reviewed telescope time allocation process. We host an open access petabyte scale data archive, and we host science-enabling software platforms for data-intensive astronomy. So I'll give a quick update in each of these areas, and I'll also encourage you to attend our science-focused demo splinter session that's at 4:10 p.m. Eastern time today. And you can also contact me directly by email, that's in the upper right there, with any comments or questions or ideas that we don't have a chance to discuss at this week's meeting. Next slide, please. Open access observing is, of course, one of our essential functions at NOIRLab. Anyone can apply through NOIRLab every 6 months for peer-reviewed access to all NSF-funded OIR observing time. This includes time on NOIRLab telescopes, of course, such as Gemini, SOAR, and Blanco, as well as open access time on non-federal telescopes made available through NSF's Mid-Scale Innovations Program, or MSIP. That currently includes Las Cumbres Observatory, the Chara Array, and starting in 2021B, Keck. We do allow multi-facility proposals as well as proposals for time domain and target of opportunity science. Most of the facilities that we offer are continuously upgrading their time domain capabilities. So you can check for the latest details in the calls for proposals that come out in September and in March. Another exciting development is that we have an all new proposal system coming soon. This will replace the long-serving NOAO legacy proposal interface that many of you know well. This new system is going to have a more modern look and feel. It should have significantly enhanced performance and usability, and also greater flexibility for upgrades and changes. Also, as Pat and Beth mentioned, this new system will provide support for dual anonymous proposal review, which is an important element of continuing our proactive efforts to broaden participation and remove barriers and biases. We're planning to release this new system for the 2022A call for proposals in September, so do stay tuned. Next slide, please. So one of the revolutionary changes that's happened in OIR astronomy over the last 20 years, and is of course still going on, is and increasing into the future, is that pointing a telescope at the sky is no longer the only way to do observational research. Now you can also point a query at a database. And so to support this new mode of science, CSDC operates NOIRLab's Astro Data Lab. This is an online environment that enables high-level exploration, analysis, and visualization of massive catalog and image databases coming primarily from NOIRLab's 4-meter class telescopes, and in particular from the dark energy camera at the Blanco, which collectively now cover over 3/4 of the sky. Listed here are four, in the upper left here, are 4 major new survey data sets that are just now coming online for public use in Data Lab. Collectively, these span science from moving objects in our solar system on up to large-scale cosmology and really everything in between. The other big new development is a recent release within Data Lab of survey-scale spectroscopic data access services, which will let you access and analyze astronomical spectra, not just by onesies and twosies, but by tens and hundreds of thousands. This is driven primarily by future public releases of spectra from the DESI survey, which you'll hear about from Lori. And it's available now for spectra from the Sloan Digital Sky Survey, public spectra from SDSS. Looking towards the future, our plan is to keep providing new ways to bring big data and big computing capabilities together, and in particular to enable combined analysis of Rubin's LSST with many other surveys, big, medium, and small, including but not limited to the headline Roman and Euclid surveys that Bob mentioned. Next slide, please. CSDC's current major contribution to the time domain and multi-messenger astronomy landscape is the Antares Event Broker. This is a general purpose online platform where anyone in the community can implement their own filters on real-time astronomy alert streams. It's running right now for the NSF-funded public surveys of these wiki transient facilities, ETF, and it's been built and tested to be scalable to the rate and volume of alerts that will come from Rubin's LSST in the near future. You can create an account and check out the system at the URL address shown here. You can implement your own alert stream filters in Python. You can get fast access to the full alert history at any point in the sky. You can upload custom watch lists of objects to monitor. And when events of interest appear in the alert stream, you can be notified via the web page or a Slack message or a programmatic interface, an API. And Antares can also be integrated with software-driven follow-up observing capabilities. Next slide, please. And speaking of follow-up, of course, one of the most exciting things about NOIRLab is the combination of wide field data-intensive survey astronomy with powerful high-resolution follow-up capabilities. And we also provide data system support for the latter. We recently released an all-new Astro Data Archive, which serves PI and archival data from Cerro Tololo and Kitt Peak. It has a modern software interface. It has very fast and flexible search capabilities, and it provides both interactive and programmatic interfaces. We've also launched 2 new data systems initiatives to support Gemini science users. First, we have started hosting high-level data products delivered by Gemini's large and long programs in the Astro Data Lab, starting with the Go Green survey of galaxies and clusters above Redshift 1. So this provides a publication service for survey teams and also a science enabling resource for archival researchers. And we expect other LLP data sets to follow. CSDC also hosts the US National Gemini Office. This is a group that provides advocacy and support for US Gemini users in the context of Gemini's international partnership. The US NGO team has recently released a set of example data reduction notebooks that you can find online at the address here. These use both traditional IRAF approaches as well as new methods using the Dragon software that Jen described. Our long-range plan is that NOIRLab will be a multi-mission national archive for ground-based OIR data, much in the same way that MAST and URSA serve for space data. As part of this, we envision increasing integration between the data science platforms, supporting all NOIRLab telescopes, while continuing to reflect and enhance the unique strengths of each one. And looking further down the road to an aspirational future where the US community has a 25% or greater share of both TMT and GMT observing time, we're also planning for delivery of full-featured data systems for those telescopes. And with that, I will hand it over to my colleague, Lori Allen.
All right. Thank you, Adam. Good day, everybody. Thanks for joining. I'm Dr. Lori Allen, and I'm the director of NOIRLab's mid-scale observatories, which includes Cerro Tololo and Kitt Peak. We aim to provide well-instrumented and high-performing 4-meter class telescopes to our user community, as well as platforms with our smaller aperture telescopes for the science and education missions of our many tenant operators. The heart of our MSO program is the group of 4-meter class telescopes shown here. We're using the wide field capability of Blanco and Mayall, along with state-of-the-art instrumentation, to perform large cosmology surveys and numerous smaller scale surveys in fulfillment of the goal expressed at the top of the slide to lead in ground-based survey and data-intensive astronomy. We're utilizing rapid response imaging and spectroscopy on the Blanco and the SOAR telescope, and supporting that effort on some of the smaller apertures operated by tenants to be a leading resource for US time domain astronomy. And finally, with NUID and Chiron on the WIN 3.5 meter and the CTIO 1.5 meter telescopes respectively, we're doing precision radial velocity measurements of extrasolar planetary systems. If you want to know more about any of these programs or the capabilities of these telescopes, please do stop by our booth after the town hall to chat with me and others about these. Now, if you've ever been on Kitt Peak, next please, you will have seen that we fly the flag of the Tohono O'odham Nation because the observatory is on Tohono O'odham lands. As Pat has already expressed, all of us here are fortunate to have the privilege to do research from atop Yolgam Duak or Kitt Peak. And I just want to take this opportunity to acknowledge my thanks to the Tohono O'odham Nation, which has been very supportive of Kitt Peak operations throughout the pandemic. We've been in regular contact with the Tohono O'odham Unified Command, which is a group set up to handle all things COVID-19 related. And they have visited the observatory to see our operations under the pandemic, They've given their full approval and they've been extremely supportive. And I just want all of you to know that. And I want to thank the nation here for that support. Next slide. If you could be on Kitt Peak today, you could see DESI in action. The dark energy spectroscopic instrument is a stage 4 dark energy experiment from the Department of Energy's Office of Science, led by a group at Berkeley Lab. DESI will use 5,000 fibers spread over a 3-degree diameter field of view to feed 10 spectrographs and measure the redshifts of approximately 35 million galaxies. DESI is currently in survey validation, which means it's taking real science data, like the spectrum shown here of a quasar, and like the more than 50,000 well-measured redshifts that were acquired during a few-week period in December, shown here on the right. DESI will not be idle during bright time. It will be probing dark energy on smaller scales with the Bright Galaxy and Milky Way surveys. Shown at the bottom right of the slide is an image of M33 from the DECAL survey with a DESI field of view superimposed. And you can see the edge of the DESI field described by the thin yellow arc and all of the little blue hexagrams there. Each hexagram represents a single fiber positioner. Next slide, please. From wide field spectroscopy to wide field imaging, this is a Z-band depth map from the Dark Energy Camera Legacy Survey's final data release, which went out this week. Much of this data was obtained with the Dark Energy Camera, or DECCAM. Next. Although observing for the Dark Energy Survey itself concluded 2 years ago, the Dark Energy Camera, or DECCAM, is still very much in demand, and we schedule about half of Blanco's time for survey and long-range programs that enable a wide range of science, whether it's probing dark energy on galactic scales, as in this galactic bulge survey image in the lower left, or mapping the star formation history of the large and small Magellanic Clouds, as in the SMASH survey here in the middle, or if it's determining the galaxy cluster mass distribution derived from weak gravitational lensing, as in this local volume cluster survey shown upper center. Next. Next year, we'll be expanding the wide field imaging capability of the Blanco by bringing NUFIRM back down to the Southern Hemisphere and making it available through open access. And that will enable deep imaging of star forming regions like NGC 6334 shown here. Couldn't resist. Next slide. Okay, so NUID is at the WIN 3.5 meter observatory. NUID is the precision radio velocity spectrometer commissioned by NASA and built by a group at Penn State. NUID is currently in commissioning. It is the core of a joint NASA NSF NN Explore program, which was set up expressly for the characterization of extrasolar planetary systems. Shown here is an encouraging plot from commissioning that shows a number of measured radial velocities for a bright star and a measurement precision that approaches NUID's performance goal after accounting for short period stellar pulsations. Now, to get a handle on short period stellar pulsations and how they impact the radial velocity data, NUID has a small auxiliary solar telescope shown pictured here, which monitors the sun daily, feeds those data through the NUID spectrograph, and then onto the pipeline at NextSci. Next slide. And finally, at SOAR, where we have enabled rapid response capability with multiple instruments, spectroscopy in both the optical and near infrared is contributing to the field of time domain astronomy. At left you see a series of optical spectra taken with the Goodman spectrograph and larger telescopes of a rapidly evolving blue optical transient, showing the spectral evolution of this source in its first 100 days from a nearly featureless flat spectrum at the top to the emergence of strongly redshifted hydrogen and helium lines at the bottom. And on the right, a spectrum in the near infrared taken with triple spec 4 of a calcium-rich supernova in M100. Next slide, please. And so this year, this is what we're focusing on. And much of this is pro forma. Naturally, we want to get the DESI and NOIRLab surveys fully operational. And we're right on track to doing that. We've already started discussions of the future of the Mayall telescope and DESI. If you'd like to be a part of that future planning, please contact us. Good ideas are always welcome. We're always trying to expand our imaging capabilities as described here. We always work to strengthen relationships with our local communities, especially the local indigenous communities and the Tohono O'odham Nation, and with our operational partners. And then finally, we'll be engaged in the relentless, unending battle to protect our dark skies. There's a lot of great work going on in this field all across astronomy and industry. And you might want to check out the session later today, brought to you by the AAS's own Committee on Light Pollution, Radio Interference, and Space Debris. And with that, I'll hand it back to Pat to take us home. Thank you.
Thank you very much, Laurie, and all of the other speakers. Just wanted to wrap things up with a few simple thoughts. I think we've heard at every talk at this meeting that 2020 was a challenging year. It was not the year that any of us expected. And the prospects for 2021 are good, but they still will require some patience. Things are not going to return to normal very quickly. But as you saw from all the presentations, nonetheless, we have a number of exciting capabilities coming online, new instruments, new software, new data sets, and of course, a whole new observatory that's under construction in Chile that truly will be transformative. We look forward this year to welcoming observers back, to engaging with you all face-to-face. It's been a challenge. We've done, as a community, I think, remarkably well with remote engagement, but we're really looking forward to seeing you all face-to-face. So hang in there. We have to all be patient, but better times are coming. We then go to the next slide. I want to close on one really important thought, that so much of what we do is only possible through partnerships and the support of a very diverse and engaged community. We are, of course, a National Science Foundation center, and we appreciate the support that they provide us, in particular, the support that Ralph Gahm and his team have provided as we've stood up this new organization. It's been complex, it's been challenging, but they've been partners with us all the way. So thank you all very much. I also want to thank the Department of Energy's Office of Science. As you heard, so much of the exciting cosmology that has been done, is being done, and will be done by our facilities is done in partnership with the DOE, and it's been a real pleasure working with them. And it's a real privilege now to be working with NASA on this exciting exoplanet frontier. This really has revitalized some of our facilities, and it's really very exciting science. But of course, we shouldn't forget that we work with a broad range of international and domestic partners, universities, agencies, foundations. It takes a very large community to make all this happen, and we really appreciate your support, and we value our relationships with you. We then go to the next slide. Just want to let people know that please come by the booth, and also remember where our Slack channel is. The team that you saw presenting and others will be at our booth following this presentation. We'd love to chat with people and just hear what you're thinking, answer your questions, and just chat. So with that, I'm going to turn it over to Suzanne Jacoby, who's been monitoring the Slack, and will let us know what questions may have arisen, and then we will direct them to the appropriate expert. Suzanne.
Okay. Yep. Thank you, Pat, and thank you all the presenters. Hi, everybody. We do have one question in the chat, And that is directed to Lori from Matthew Penny, asking, is COVID providing MSO any lessons on how to implement queue service for Blanco and the other telescopes?
That's a great question. We were already doing much of our observing, or our users were already doing much observing remotely with both Blanco, Mayall, SOAR, and the WIN, with all of those telescopes. But certainly this has got our attention to harden our remote operation capabilities for the future, so that we don't have to plan so carefully about who is in what control room when, in order to continue our operations when and if something like this happens again. Thank you for that question.
Okay, and more coming in. Here's one from Andrew Cooperis. A lot are coming in. Are special data processing steps being considered for Rubin LSST to handle the potentially significant contamination due to SpaceX Starlink satellites? I recall a AAS 236 talk mentioning a possible large impact from this for LSST specifically.
Yeah, I guess I can jump in. We certainly are looking at this very carefully. We have a lot already built into the data pipelines to handle streaks from satellites, because this was always suspected. And we're working very closely, in particular, Tony Tyson, with some of the commercial satellite groups to physically mitigate the light. I'm sure you'll hear more about that at the AAS session later today. And the combination of those things makes us think that we will, in fact, be able to handle the impact of the streaks on the images, which is really only something less than 1% of all the pixels. The thing that we don't yet know for sure is how these streaks, the myriad streaks, which will appear in many images, affect the systematics. And that's something that we're actually working on to simulate that, so that we can pull out some information on what that's going to look like, and then we'll go from there. So the answer is yes, we're very much working on it, and we think we're going to be okay, but we're not 100% sure about all the details yet.
Okay, there is another question here, and this one is directed to Adam from Gail Schaefer. When do we expect open access time at Keck to begin? And then a little bit more information, 40 nights over 40 years. Adam has already answered this in the channel. Go ahead and speak your answer, please.
Sure, yes, making sure I did. Yeah, so it's 40 nights total over 4 years, beginning in 2021B. So that would be starting with the next call for proposals that'll come out this spring.
Okay, another question had to do with education and outreach for all the NOIRLab facilities. And I'll answer that quickly, and I'm about to put a link in there for you, Allison Rose. All of the NOIRLab programs have very strong existing and expanding education and outreach programs, and there is a website that you can take a look at. I'd like other people to know that in that chat window too, for the questions, a lot of questions. We have all the presenters have their email addresses in there. We've presented the slides for this session, and also a link to get to the after party, which is starting in just a few minutes. Is there a one-stop website where we can find out the spectroscopic capabilities available with various NOIRLab telescopes?
So we have, good Pat, so we currently have a public website, noirlab.edu, and there is some information on that website about our ongoing projects and each of our programs. That is geared towards the public and not for the user community. We don't yet have a fully integrated one-stop shop website with that information on it. It's under development now, so we anticipate within the next several months, we will be releasing noirlab.edu for scientists, and so stay tuned for that. And if Lars Christensen, I know, is also working on that information. If he'd like to add more on the Slack channel, I know he's not on the panel, so can't. Lars, please go ahead and add on the Slack channel if you'd like.
Okay, that ends the questions that I see coming in. We have a few more minutes. We've had questions at the booth and in general that might be of interest. So here is a broad one. Do you expect there to be more remote observing support once the pandemic has ended? Who would like that one?
I'll take a first stab at that and see. I think one of the lessons that we've learned from this pandemic is one that people can do a lot of science remotely, but the other is that we should expect the unexpected. And I think we should move towards a mode where people can operate, engage with the telescopes in ways, and that some of the telescopes, we may move to the mode where they become more autonomous, that we move away from needing people to push buttons, but rather have intelligent software that can take a pre-programmed set of observations and just run with them. So I think we should see a natural evolution of less need for people to actually travel to the mountaintops. I don't think we want to prevent that, people coming if they wish to, but I think it's in everyone's interest that we reduce our carbon footprint, that we reduce our costs, that we use our time effectively and think about how to make the telescopes more modern in that sense. But I'd be very much interested in hearing from Laurie and from Jen, who operate the current large aperture telescopes, how they view that within their programs. No? Okay.
I
We're still-
I'm sorry, I was having
think Laurie
trouble
should go
finding
first. Go ahead.
sorry. I think we were waiting for each other to go first. So we're doing more Q operating on Kitt Peak and on Ceratololo at WIN and SOAR in particular to support the time domain astronomy at SOAR and to support the NOIRLab survey that will soon be starting on WIN. NOIRLab will be entirely run, will be mostly run from a Q. Certainly all of the in Explore time will be operated through Q. And, you know, we're looking at being able to extend that capability in the far future, that is not next year, to more telescopes. But as I said earlier, we already have a very sort of healthy remote observing community, and that has been working out well during the pandemic once we got the telescopes back on sky.
Yeah, I'll just note that I'm very grateful that Gemini invested in base facility operations a few years ago. It made it pretty easy to safely operate and restart Gemini North and South. Most of our observing is in Q mode. Astronomers may choose to eavesdrop or listen in while the nighttime operators are observing their targets. I think the one place that we have not been able to really effectively operate in this new era is with GEMS, our multi-conjugate AAS facility in the south, because that requires a large number of people in the same room on the summit. And so we do have a project, we actually were planning this project anyway, to bring GEMS to base facility operations so that we could operate it with fewer people more efficiently and essentially in a Q mode. So that's on the horizon and part of the longer strategic vision for Gemini and NOIRLab.
Okay, there are more questions. This one would also go to Jen. Would Gemini be considering reducing the turnaround time for the FT program to a few days from weeks?
I'm not quite sure what that means. The turnaround for accepting proposals, reviewing proposals.
It says for the FT program, and I don't
So
know
that's
what
the
that
fast
means.
turnaround program.
Oh, okay.
We have a monthly call. I think the fast turnaround and the director's discretionary programs are very complementary. So often we'll get a director's discretionary request that is maybe better suited for fast turnaround because it doesn't really require an immediate get on the sky. And we like to have peer review programs, right? We don't want it just to be at the director's discretion all the time. So I'm pretty pleased and happy with the way that we're running that. And I don't know that we can run it any faster than a month to have people review and adequately look at those and get them into our schedule. But director's discretionary is always an option if you really have a very urgent need to use Gemini.
Okay. There are a couple more questions. This one's for Pat. Since you mentioned lowering the carbon footprint, is there a deliberate effort at NOIRLab to understand and eventually reduce the GHG emission associated with its operations?
Yes, there certainly is. Thank you. That's a great question. When we laid out our 20-year vision for the organization, one of our key goals was operating the observatories in harmony with our environment. And we talked a bit about being better partners with the indigenous community. But part of that harmony is reducing our carbon footprint. So we have set goals to the energy usage at the site and our overall carbon usage. And we are trying to coordinate and understand what's going on at each of the local sites. The Chilean government has a very aggressive and so far very successful program to reduce their carbon footprint by increased reliance on renewables. Hawaii has similar programs. So yes, this is important to us and we are really acting it, but it will take some time.
Okay, I'm going to keep going with these questions. Here's one that's gotten 5 thumbs up from Peter Frenchaboy. Is there any concerns about the lack of students in-person observing training going forward in the continental US, especially from students from small schools, especially with the pullback from Kip Peak for the long term?
Certainly, there is that concern. Look, I think we can increase both the performance and efficiency of our telescopes with modern operating procedures without precluding the presence of students on the mountain to actively run the telescopes themselves or run the observations themselves from within control rooms. And that's the model that I would like to see going forward. Because yes, obviously, student training is an important part of the observatory's mission.
Okay, I'm going to try for one more question here before we overstay our welcome. And it is, will some level of exposure time calculations be available on the One Stop website, particularly for spectroscopic instruments?
Beth, you want to start?
I was going to defer to Jen or Adam if they would like to offer an answer, and then I can zoom out and say something philosophical. So please.
I will just say that I would anticipate, at least in the short term, that this NOIRLab umbrella website would point to the specific capabilities at each of the facilities and the exposure time calculators associated with that. I would also encourage you to take a look at both the Gemini program platform demo and some of the discussions around AON about more efficient ways of using Gemini North in a system for figuring out, you need a spectrum of a given signal to noise, let the system figure out what that setup looks like. And I think incorporating that kind of capability into a broader network, it would be a really fantastic resource for the user community.
Yeah, I don't think I have anything to add. I know I'll certainly second what Jen said, that the approach they're taking in Gemini is more encompassing of the entire suite of instruments rather than presupposing knowledge about the instrumentation on behalf of the proposer. This is also something that we're building in at the ground level of design for US extremely large telescope program data systems. And yeah, certainly a vision of encompassing more than one observatory and something like that is a great one as well, and something that I think would make observing much more accessible to a broader community.
Okay, well, things have quieted down and we've probably overstayed our welcome. So I'll let you finish it off. We'll keep this channel open and also the exhibit channel for further conversations. Pat?
Great. Well, thanks everyone for coming and listening, and most importantly for the outstanding questions. That shows real engagement. We're very pleased to have that. Come by the booth. There's lots more to talk about, more questions. So really, thank you for taking the time. This has been a great session. We appreciate your joining. Bye-bye.
Very good. Thank you.